Okay, so we're going to be deriving these three equations. Now, we're going to do all three in one video just for ease. So the first one that I'm going to look at is our linear function. So our linear function here. So that is f of t is equal to 205,612 over 3 t plus 14800. You'll notice that I flip back to using t because that's the one that's actually in your assignment. The x's, it's just annoying really. Okay, so this is our equation that we're using. Now, if I want to derive it, first thing I'm going to do is I'm going to state what formula we're going to be using to derive it. Now, ages ago, I made a cheat sheet for mathematical methods with derivatives on it. If your teacher didn't give this to you, it should be on your eLearn page. Otherwise, ask them to go to the drive and send it out to you, because it's handy to have them all written on one nice page. So we're going to go and we're going to be using this one here and this one below to do our first and second derivatives. So I'm going to copy them and paste them into my Word document. Now, you obviously would be typing these, but, you know, I'm just trying to show you what to do. So here we are. So they're the two formulas that I'm going to be using. So when I calculate my first derivative, f of t, and it's our first derivative, that's going to be equal to applying this rule here. So t actually has a power of 1 above it, meaning that when I derive this first portion here, I'm only left with what's in the front, because t ends up being to the power of 0. Anything to the power of 0 is 1. So our first derivative is just equal to this. And our second derivative is what we're going to be applying with that second one here. We've got a constant. When we derive it, it's going to turn out to be 0. Okay, now initially this one here, we used this first rule on this section of it, and we used this rule on this section of it. So that end part just vanished. So these are the two equations that I'll be using to calculate the gradient or the speed and acceleration of our linear portion of the function. Now the next one we're going to be looking at is our exponential portion. So again, I'm going to quickly flick back to this, and I'm going to go down to where we've got some exponential rules. So just here you can see that if it's just e to the power of x, nothing happens. But if we've got e to some function, we derive that function at the top, it comes down and multiplies the front. So I'm going to snippety snip this. Obviously, again, you'll type this. Go back to our OneNote, pasty paste that in. Okay, so now our initial function for this was this whole thing here. Now I'm just going to write y equals so that you know, f t equals so that you know you would have had to have stated it again. Now we're going to state the first derivative of that function. So when I do the first derivative of this function, this constant out the front is going to multiply whatever we get. Sorry, I should say coefficient out the front. Now, when I take the derivative of this top thing here, you can see that this portion here on the end is the only part that has a t. So if I'm trying to derive this end part, this is just a number. This part here is just an ugly number. You can have ugly numbers just like you can have ugly people. So if that was like 3 plus... Now, this part on the end is also just an ugly number. It's just got a t on the end. We've just left it in an exact form to not get rounding errors. So plus, let's say that that was 2t. If I want to derive this, I end up with just d over dt is equal to 2. So that's what it would be left with. So when I'm thinking about deriving this portion here, the only part that needs to come down is this part here. When I derive the bracket at the top here, this is what remains. So now I can write that back in. 1 over 3 ln 299,123 over 552 e to the power of And now the power above it, just like over here in our formula, this power above doesn't change, so this one's going to stay the same as well. So it's just going to be negative 2 ln bracket 299123 over 552 plus 1 over 3 ln bracket 299123 over 552, and then there should be a t on the end of that. Okay, now when we calculate our second derivative of this portion is still the only part when I derive this thing at the top here that's coming down. So really, it's going to be the same, except now this portion here, the part that was derived brought to the front, now I've got two of them multiplying each other. So I can just replace that with squared. So now E bracket's going to be the same, minus 2 ln bracket 299123 over 2 plus 1 over 3 ln. You think I'd be sick of writing this number by now, but look at us go. And then there's a t on the end. So now I've got my two functions for that look like that. Okay, so now the next part we're going to do is our trig portion of this. So we're just going to scroll down. I'm going to go back to my derivative rules over here. I'm going to scroll up, and I'm going to look at what it's doing here. So now I can get my snippy snip. Got my snippy snip. Sine and cosine functions. I'm just going to copy that little bit there. Copy. And I'm going to go back over here. Chuck it in. Obviously, again, for you guys, you will be typing this. So, y equals. Now, the original function we had was minus 282, 1, 2, 3, 4, 5 zeros. Sine, bracket, pi on 22, close bracket. Oh, sorry, open another bracket. X minus 9, close bracket, plus 2, 9, 1, 2, 3, 4, 5. There's another 9 squeezed in there that I left out. So now, when I take the derivative of this, just like we did here, if that's my function and I've got a function inside of it, I take the derivative of that and it comes to the front. So I'm going to take the derivative of what's in the bracket here. Now, if you think about expanding that bracket, if that's my function and I derive it, then I'm only going to be left with this. So that's the part that's going to come down and multiply. So minus 282, 1, 2, 3, 4, 5, pi on 22. Sine is going to change into a cos. The bracket doesn't change. Just like here, the bracket doesn't change. And now when I try and derive this n portion, because it's a constant value, it's just going to vanish as well. So that's my final answer for the first derivative. When I calculate the second derivative, all I need to do, take the derivative of this bracket, and it's going to come down and multiply this portion as well. So minus 282, 1, 2, 1, 2, 3, pi on 22 squared. Cos is going to change into minus sign, meaning the minus will come to the front, change that to a positive. And now the bracket inside doesn't change. Now, it's up to you. You can clean this up a little bit, multiply these numbers together. But I just did this for ease so that you can see what it'll turn out to look like. So I would, in the assignment, expect you to go back and clean these up. But they are all of the functions that I'm going to be using in the next video to get our speeds and accelerations of the growth of this channel.